Hello, hope you're having a great day today. Today we're going to be talking about rational expressions. So rational expressions are simply where you have a ratio or a fraction where there's a variable involved, okay? So all our rules for adding, subtracting, multiplying fractions are very important for this section, as well as all your rules for being able to factor, okay? At the end of the day, we'll be able to simplify rational expressions and multiply and divide rational expressions. All right, simplest form. Numerator and denominator are polynomials that have no common divisors, okay? So for example, this guy is in simplest form right here, in simplest form right here. In other words, there's nothing I can cancel top to bottom anymore in those. This guy, well, I can cancel here. This is x to the first over x squared, so I can rewrite this as 1 over x. This, I can't necessarily cancel this fraction over x plus 1. But what I can do is I could rewrite this as 1 over x times 1 over x plus 1. Being able to multiply and divide fractions is going to be crucial here, because now I would write this as 1 over x squared plus x, and now I'm in simplest form. Okay? This right here, I can cancel this last one right here. I can cancel right here and call that just 2 over 3. Now, Mr. Roderick, why can I cancel here but not over here with this first one? Why can't I cancel x over x there? Okay, so we need to have that discussion. All right. All right. Consider this. Okay, because this is really important. Okay, let's say you have 24 over 23. Okay. Well, you could. This is true. You could call this 20 plus 4 over 20 plus 3. That's a true statement. Okay. But if I do this, I get 4 over 3. Is 4 over 3 the same as 24 over 23? My original fraction, if you will? That is not true. So this example right here is all you need to be able to see, hopefully, that when you've got basically terms, okay, things that are divided by plus or minus signs that you cannot cancel. But if I have factors, like this right here, this x minus 3 is a factor over this x minus 3 in this fourth little example here. Those I can cancel. Okay, the whole piece. I can cancel whole pieces. I just can't cancel pieces and parts. Okay, so let's move into some examples, because this is in my past experience, this seems to be the biggest problem you have problems with, is whether or not you can cancel. Okay, so again, the factoring situations, I'm not going to go through all these, but basically we can factor with tic-tac-toe. We can factor with difference of squares, right? That's 2x plus 3, 2x minus 3. Tic-tac-toe if I need to. And greatest common factor coming out. Remember, this is 10x times x minus 1, right? If I factor that out, okay? Multiplication, we can multiply straight across, multiply fractions, but I can also cancel here, make that a 2 there. All right. Division of fractions, 3 over 4, sorry, times 2 over 1, right? Flip and multiply. 2, 1 there. We can do that sort of thing. And again, division here, just to reiterate, so important. We get here is x over 4 times 6 over x squared, and then we get lots of cancellation. Once I get multiplication, I'm allowed to do lots of cancellation, right? If it's basically, it could be one big long line. Okay, so this is 3 over 2, And then you just multiply fractions straight across, right? So this would be 3 over 2x. Okay? All right, so let's get into our examples. And we don't have very many of them. We're basically going to do so simplify. Again, there's no equations here. We're going to do equations later. This is just simplifying expressions today. All right? So if I want to do this, basically the first thing I need to do is factor the top and bottom. Okay? So things that multiply to negative 16 and add to negative 6. So we've got x minus 8, x plus 2, over on the bottom, things that multiply to get to 6 and add to get to 5. X plus 3, x plus 2. Okay? Now, I've got whole pieces here of x plus 2 and x plus 2. I can cancel there. That's perfectly permissible. And that's what the simplification is actually asking you to do. Okay? So my final answer is x minus 8 over x plus 3. Okay? State restrictions on the variable. So what have we been talking about for restrictions on the variable? Things that basically at this point that should translate as things that are going to make the denominator 0. Okay? Now even though we've canceled out the x plus 2, we still have to state x cannot be equal to negative 2. And with this x plus 3 still here, x can't be negative 3 either. Okay? All right. Now these quick checks for this one, I'm going to do the first one because it looks a little bit differently, but you're still doing sort of the same sorts of things. Okay? And we'll do these other two in class. All right. So we've got negative 27 x to the third y over 9 y. 9x to the fourth y, I should say. So negative 27 over 9 is negative 3 over x to the first, and the y's cancel. Okay, so that's my answer, but I do have to state that x and y, neither one could be 0. That would be bad. Again, notice cancellation is permissible there because there's no addition subtraction signs. That's all multiplication. So that's one big piece over one big piece, and I'm just multiplying, taking factors out. Okay, so that is perfectly permissible. Okay, let's go ahead and move into a multiplication. Okay, so if I multiply, I'm still doing kind of the same sorts of things. All right. So I need to factor. So let's go ahead and review our tic-tac-toe here real quick. So 3 minus 2. So I get minus 6 here. And then we're going to fill in with 6 and minus 1. Things that multiply to get to negative 6 and add to get to positive 5. All right. Factoring right here. All right, so we get in our box, we get 3 and 2 here, 1 and negative 1 there. So I get 3x minus 1 and x plus 2. Okay, over x minus 5. And then on the other side of that, I'll do that in a different color here. Go ahead and factor this guy. Whoa. There we go. This guy here. Okay, so I'm going to use the same factoring method. Go ahead and do that down here in the bottom. And I get 3 and positive 2 this time. Still get to 6. Things that multiply to 6 and add to get to negative 7. Okay, so this 3 has to go here. This 1 has to go here. Minus 1, minus 2. So this turns into, we get x minus 2 and 3x minus 1. And that's in the denominator, I'm sorry. Okay, and all right, that is in my denominator. The top, hopefully we recognize as difference of squares, x plus 5, x minus 5. Now, the nice thing here is all these factors I can cancel top and bottom because multiplication, again, it's like one big long setting that I'm looking at now, okay? So I can take this x minus 5, let's use black here, x minus 5, and this x minus 5 can go away, and this 3x minus 1 and this 3x minus 1 can go away, and that's basically it. So I've got x plus 2 times x plus 5. You can write it like this. You could multiply it back together if you so desire. I would probably accept either. I'm actually or x minus 2. Okay. All right. So you could write it that way. That would be fine. Now, we do have to state again that x can't be x is not equal to, let's see here. We've got 5 would be bad. 1/3 would be bad. And 2 would also be bad. Okay, all things that would make the denominator 0, and those are the things that we want to state. X is not equal to those. So put a little comma there. So your answer is right here. This is my final form. Again, you could multiply that back out as a quadratic or not, and then what things that x can't be. All right. So that really brings us to our last example, which is division. Okay. And the only thing different with division is to start, I have to go 3 minus y over 2x minus 1, x plus 5, times, right, 2x minus 1, x minus 7 here, over 6 times y minus 3. Okay, now, before I go any further, I'm going to go ahead and start stating some restrictions here so I don't forget them. With right here, even though this is going to get flipped to the top, I have to say x can't be 1/2 and x can't be 7 right away. Okay? All right? Because at some point right there, it would mess up my denominator, so I have to include that. Okay? All right? So now we get to do a couple other quick little features here. This 3 minus y and this y minus 3 are pretty close. What I can do, and this is perfectly legal, rewrite this as minus 1 times y minus 3 here. Basically change these signs here so I can cancel. Okay? Everything else stays the same. Okay, 6 times y minus 3. Okay? So now I can go ahead and cancel. And you're basically done. Okay? So I'm going to wrap this up here. We got x can't be these. They can't be -5 would be bad as well. Right? And +3 would be bad. Okay? All right? And basically your final answer would just be -1 x minus 7 over 6 x plus 5. And you could express it that way. You could multiply that out together, whatever you so choose. Okay, so simplify basically straight away. Simplifying with multiplication and division is what you can do today. Hope you're having a great day, and we will work on this more in class.